Okay, so you know when you get a glass of water and you pop some ice cubes in, they just float, right? They bob around on top like tiny little boats. But have you ever stopped to think, why? Let's get into it. It's actually a super cool mystery.
I mean, really think about it for a second. If you toss a rock into a pond, plunk, straight to the bottom. A coin, same thing, sinks right away. But water, when it turns solid into ice, it does the complete opposite. It floats. So what's up with that? What's going on here?
You know what? That's exactly it. Ice is a total rule breaker, a little frosty troublemaker that just refuses to play by the same rules as all the other solids. Seriously, it's one of the weirdest and, let's be honest, coolest tricks nature has up its sleeve.
All right, so if we're going to figure this out, we need to think like detectives. So grab your magnifying glass, put on your detective hat. Let's get to the bottom of this chilly mystery.
Okay, every good mystery needs a suspect, right? Well, our number one suspect is the water molecule itself. Yep, to crack this case, we have to understand this tiny, tiny little thing that makes up all water.
Whoa, check out that shape. A water molecule, you might have heard it called H2O, isn't just a boring little ball. No way. It's bent. It kind of looks like a boomerang. Or, you know what it really looks like? Mickey Mouse ears. And that weird shape, well, that's our very first clue.
So let's break this down. You've got one big oxygen atom in the middle, that's the O, and then you have two smaller hydrogen atoms, the H2. Now, because of the way they're all stuck together, it's not perfectly balanced. One side of the molecule is a little bit positive, and the other side is a little bit negative.
So there's a sciencey word for this. It's called polarity. But really, all you need to remember is that it makes each water molecule act like a teeny tiny magnet. And what do magnets do? They stick to each other, right? That's why water molecules are kind of like super clingy friends. They're always trying to grab onto their buddies.
So, what happens when all these little magnetic, boomerang-shaped, clingy friend molecules start to get really, really cold? Well, this is where the story gets super weird. Okay, as things get colder, the molecules lose energy, so they start to slow way down. No more zipping and bouncing all over the place. They start to get organized and line up. Now, you'd think they would all huddle together to get cozy, packing in super tight, right? Nope, wrong. In a totally crazy plot twist, they actually push each other away. They expand. And here's the reason why. Remember that boomerang shape? Well, because of that shape, they can't just smush together neatly. Instead, they have to lock into place in this really specific, beautiful pattern. It's called a crystal lattice. And the most important part? Look, it creates all this empty space in between them. Honestly, the best way to picture it is like bubble wrap, but for molecules. All those little pockets of nothing, all that empty space, makes the whole thing surprisingly light and airy, even though it's now a solid chunk of ice. Okay, let's review our clues. We've got boomerang-shaped molecules that act like magnets, and when they freeze, they build a crystal structure full of empty space. I think we have everything we need. It is time for the big reveal. The whole solution to this entire mystery comes down to one single word: density. Now, don't let the word scare you. Density is just a simple way of talking about how much stuff is packed into a space. Like, imagine a shoebox full of rocks. It's way more dense than the same shoebox full of fluffy feathers. And this is the key right here. In liquid water, all those molecules are just sloshing around, all jumbled up and packed together pretty tightly. But in ice, remember that crystal pattern? The molecules are all spread out with that empty space between them. So if you take the exact same amount of space, there's just less stuff in the ice than in the water, which means ice is less dense.
And that is it. That's the answer. It's just a basic rule in science. Things that are less dense will always float on things that are more dense. It's why a giant tree log can float on water, but a tiny little pebble sinks. And it is exactly why our amazing rule-breaking ice floats. Mystery solved.
But wait, we're not done, because this isn't just a fun fact to share at parties. This weird little rule about ice floating, it turns out it's one of the most important things for, well, pretty much all life on Earth. Just stop and imagine for a second. What if ice acted like everything else and sank? Well, in the winter, lakes and rivers would start freezing from the bottom. And then the next layer would freeze, and the next, until the entire thing was one giant solid block of ice. And for the fish, the plants, and everything else living in there, game over.
It would be a complete disaster. But thankfully, ice does float. So instead, it forms this protective layer right on the surface of the water. This ice layer acts like a shield, insulating the liquid water underneath from the freezing cold air above it. So everything under the ice stays liquid and all the fish and plants can survive the winter, safe and sound.
So, a perfect way to think about it is that the ice is like nature's very own winter blanket. It just covers the whole lake and keeps everything underneath nice and cozy. Well, not too cold anyway. Until spring comes back around. It's an incredible, life-saving design.
So, the next time you're about to take a sip of your drink and you see that little ice cube floating there, just take a second to look at it. Because you're not just looking at a chunk of frozen water. You're looking at a tiny, planet-saving rebel, a frosty little rule breaker that makes almost all life on our world possible. Now, how cool is that?